Welcome to today's lesson on resolving forces. Today, we will begin by discussing why forces sometimes act in directions that aren't straightforward. With this established, we'll explore how complex diagonal forces can be split into two separate forces, one horizontal and one vertical, which together have the same effect as the original force. Finally, we'll introduce trigonometry as a tool to find these component forces. So far, you have learned that the resultant force is a single force that has the same effect as all the original forces acting together. Building on this foundation, we can now dive into resolving forces. Forces can sometimes act in directions that aren't straightforward to work with. Imagine pushing a box diagonally across the floor. The direction of the force you apply isn't purely horizontal or vertical, it's somewhere in between. These kinds of forces can be complicated to work with directly when trying to analyze their effects.
So, how do we make sense of these forces?
Well, to make it easier, we can break down this complex force into simpler parts. This breaking down process is called resolving the force into its components. To understand how this works, let's go back to our example of pushing a box diagonally with a force of 10 newtons. The force you apply can be viewed as two separate forces acting at right angles to each other, one pushing horizontally to the right and the other pushing vertically upwards. These two forces are called the component forces. Together, they have the same combined effect as the original diagonal force. Now that we understand what resolving forces means, the next step is to learn how to find these component forces. To do this, we need to use trigonometry. You may remember from your maths lessons that when we are given a right-angled triangle as shown, we can use the trigonometric functions sine, cosine, and tangent to find missing angles or side lengths. Well, we are going to use this trigonometry to find the component forces. When a force makes an angle with the horizontal, we can use the following trigonometric functions to find its components. The horizontal component can be found using the cosine of the angle, and the vertical component can be found using the sine of the angle. Let's take a specific example to see how this works. Suppose you push a box with a force of 10 newtons at a 30-degree angle to the horizontal. We want to resolve this 10 Newton force into its horizontal and vertical components. Let's start with the horizontal component. Using trigonometry, the horizontal component can be found using the cosine function. We calculate it as horizontal force equals 10 newtons multiplied by cos of 30 degrees. The cosine of 30 degrees is approximately 0.866. So the horizontal force is 10 newtons multiplied by 0.866, which is 8.66 newtons. Similarly, the vertical component is found using the sine function. We calculate it as vertical component force is 10 newtons multiplied by sine of 30 degrees. The sine of 30 degrees is 0.5. So the vertical component force is 10 multiplied by 0.5, which is 5 newtons. So the original 10 Newton force applied at a 30-degree angle to the horizontal can be effectively thought of as two component forces. The first is 8.66 newtons pushing horizontally to the right, and the second is 5 newtons pushing vertically upwards. These two simpler forces together create the same effect as the original 10 Newton force. Now that we've covered the main concept and example, we'll move on to some practice problems to help solidify your understanding. A force of 5 newtons is applied at a 45-degree angle to the horizontal. Resolve this force into its horizontal and vertical components. First, let's tackle the horizontal component. We know that to find this component, we need to use the cosine function. Therefore, the horizontal force is 5 newtons multiplied by cosine, 45 degrees. The cosine of 45 degrees is approximately 0.707. So the horizontal component force is 3.54 newtons. Now for the vertical component. For this, we use the sine function. So the vertical component force is 5 newtons multiplied by the sine of 45 degrees. Sin of 45 is also 0.707. We get an answer of 3.54 newtons. So, the 5 Newton force applied at a 45-degree angle to the horizontal resolves into a 3.54 Newton force acting horizontally to the right and an additional 3.54 Newton force acting vertically upwards. Let's look at another question. A force of 12 newtons is applied at a 60-degree angle to the horizontal. Resolve this force into its horizontal and vertical components. First, let's calculate the horizontal component. Using the cosine function, we find that the horizontal component is 12 newtons multiplied by the cosine of 60 degrees. Since cosine of 60 degrees is 0.5, we get an answer of 6 newtons. Now for the vertical component. For this, we use the sine function. We find that the vertical component force is 12 newtons multiplied by the sine of 60 degrees. Since sine of 60 degrees is approximately 0.866, we get an answer of 10.39 newtons. So, the 12 Newton force applied at a 60-degree angle to the horizontal resolves into 6 newtons horizontally to the right and 10.39 newtons vertically upwards. By working through these examples, you can see how we use trigonometric functions to break down complex forces into simpler, more manageable components. This technique simplifies our analysis and helps solve problems involving forces acting at angles. Well done today, let's recap. In this lesson, we delved into the concept of resolving forces. We understood that forces acting at angles can be complex, and breaking them down into simpler, perpendicular components, horizontal and vertical, can simplify analysis. We also discussed how we can use trigonometry to calculate these component forces by using the cosine function to calculate the horizontal force and the sine function to calculate the vertical force. Watch the rest of the GCSE physics course at Sophos Education.